Hi everyone, we're going to work on some chapter 3 homework problems, and we're starting out with some vector and trig problems. So here goes. Number 1. Two workmen are trying to move a heavy crate. One pushes on the crate with a force of 445 newtons west. The other pushes with a force of 325 newtons north. What is the resultant force on the box? Give both magnitude and direction. Now, if you recall, by convention, if you are dealing with north, south, east, and west, it is considered convention to have north at the top of your page, south at the bottom, east to the right, and west to the left. So as I draw my vectors, I am going to start with this 445 Newton west. I'm going to put a vector towards the left, 445 newtons. Acting on the same object is 325 newtons going to the north. Now this is a little bit smaller, so I'm going to draw it a little bit smaller in size. This is aiming towards the north, excuse me, and this is aiming towards the west. Now currently my vectors are tail to tail, and they must be nose to tail in order for me to add them. So how do I do that? I have to pick up one vector and move it. It does not matter which vector you pick up. I'm going to pick up the 325, keep the orientation, keep the same size, and move them so that they are nose to tail. Then I draw a resultant from the tail of the first to the nose of the last. Now, if you had decided to move instead of the 325 Newton vector, if you had decided to move the 445 Newton vector and move that one up nose to tail, you would have ended at exactly the same spot and created a parallelogram. So which vector you choose to move, you cannot make a wrong choice. All right, now this is the triangle that I'm going to work with, this one right here that I'm outlining in red. This is a right angle. In order to find the size of this resultant vector, I'm going to use Pythagorean's theorem. A squared plus b squared equals c squared. So that's going to be 325 newtons squared plus 445 newtons squared. And the square root of all of that will give me the length of this hypotenuse. And when I put that in my calculator, I'm going to pick up my calculator, 325 squared plus 445 squared. Add those together, square root the sum, and I end up with 551. These things have the units newtons, so this value has newtons. That is the magnitude or size of my resultant vector, but what about direction? Now we have to give directions that make sense. Well, west I know is 270 degrees. So if I find this angle theta, I can add that angle to 270 and come up with a compass heading. So how am I going to find theta? Well, to find theta, I'm going to say that this side is the adjacent side to my triangle. The side that does not touch this triangle is the, or this angle is my opposite side, and the long side is the hypotenuse. I'm going to try and use my given data instead of what I solved for, mostly because Mary makes mistakes, and I want to avoid carrying through my mistakes. So which trig function, if I use SO, CA, TOA, which trig function has adjacent and opposite? Well, tangent has adjacent in it, cosine has adjacent in it, sine does not have an A in it, so it's not that. So which other one also has opposite in it? That's going to be tangent. So that's how I'm going to choose which trig function to use. The tangent of the angle is going to be the opposite over the adjacent. The opposite is 325. The adjacent is 445. That is the side that is next to that angle. And when I divide 325 divided by 445, that is the tangent of my angle. And in my calculator, 0.73033 and extra bits. Now that's not my angle, that's my tangent. How do I go from the tangent to the angle? In your calculator, you have to either type in second tangent or inverse tangent, or you have to go tangent to the -1 power. Depends on how your calculator is programmed. And when you do that, I am going to get an angle of 36.1 degree, and that's not finished yet, because what that is this degree right here, but it's not, doesn't mean anything. I've got to put this direction in relationship to the compass. So I'm going to add the 36 plus the 270, which is straight west. And if I add 270 in my calculator, what do I get? I get 306 degrees. So what is the complete answer? This is the magnitude of my vector. This is the compass heading of my vector. And that's where the resultant vector is going to push. Let's do another one. Let's do number 2. A shadow is used to determine the height of a tree. The tree casts a shadow 47.2 meters away from its base. So this distance is 47.2 meters away from the base. This image is for the next problem, so we're going to ignore that. So 47.2 meters away from the base. And it rises 50 degrees above the horizon straight to the top of the tree. How high is the tree? So this is a simple trigonometry problem. Let's take a look at this. If this is my angle right here, the 47.2 is what side? That's going to be my adjacent. The long side of the triangle, this is going to be my hypotenuse, and the side over here that does not touch this angle, that's my opposite. So which trig function do I use? I go back to SO, CA, TOA. I want something that contains adjacent. So that's going to be either tangent or cosine. I do not have adjacent in sine, so I cross that out. And I'm looking for opposite. So which one has adjacent and opposite? Where cosine does not have an O in it, no opposite, so I'm going to use tangent again. So the tangent of my angle is going to be opposite over adjacent, and the tangent of 50 degrees is going to be the opposite side divided by the adjacent, which is 47.2 meters. Now, when I plug this into my calculator, my opposite side, which is what I want, is going to be equal to the tangent of 50 degrees multiplied by 47.2 meters. So now I'm going to pick up my calculator. I'm going to plug in 50 tangent, that's how my calculator works, times 47.2, and I ended up with 56.3 meters is the opposite side, which is the height of my tree. Let's do another one. Number 3. The maximum allowable pitch for a handicapped ramp is a 5-degree slope. If you need to build a 5-foot tall ramp to allow someone in a wheelchair to get into your home, how long must the deck of the ramp be? So here's our little triangle. The whole ramp, it has to rise 3 feet. Maximum pitch or slope is 5 degrees. Here is my right triangle, and I want to know the length of this side. Now, if you look at this, what is that side? Adjacent, alternate, or hypotenuse? Which one is that? That's going to be my hypotenuse. If that's going to be my hypotenuse, and this is the angle I'm talking about, the side next to the angle, that means this is the adjacent, and the 3 feet tall, this is my opposite. So I know my opposite, and I'm solving for hypotenuse. Which trig function do I use? So I go back to SO, CA, TOA. Which one of these has opposite in it? Because I know that value. Well, it's either going to be tangent or sine. So I can cross out cosine. I want to solve for hypotenuse. So which one has hypotenuse? That's going to be sine, and that's the one I'm going to choose. So sine of theta is going to be opposite divided by hypotenuse, and the sine of 5 degrees is going to be my opposite. Opposite of the angle is what doesn't touch that angle, which is 3 feet, divided by the hypotenuse. And when I do the math, the hypotenuse is going to be equivalent to 3 feet divided by the sine of 5 degrees. So now I pick up my calculator. 3 divided by the sine of 5, and I end up with 34.4 feet. Now you could convert that into meters or other units if necessary, but for this problem it was not necessary. Let's see if we can do one more. A boat is motoring due east across a river with a velocity of 18 miles per hour. There's a current in the river of 6 miles an hour towards the south. What is the resultant velocity of the boat? So here goes. We have a boat motoring due east 18 miles an hour. So here is a vector due east 18 miles per hour. There is a current in the river of 6 miles an hour towards the south. Both are acting on the same object. That's why I am putting a dot there to represent the boat or the object, and both of these vectors are acting on that little boat. But when you add vectors, you must make them nose to tail. Does it matter which one I pick up and move? Nope. So I think this time I'm going to pick up the 6. Why? Because I want to. So I'm going to pick up that 6 and I'm going to move it over here. And you draw your resultant from tail of the first to the nose of the last. It's going to go like that. And I need to find the resultant size and the direction. So here is my right triangle. In order to find the size of this resultant vector, I'm going to use Pythagorean's theorem. A squared plus b squared equals c squared. So I'm going to have 18 miles per hour squared plus 6 miles per hour squared, square root of the entire ball of wax. I'm going to plug that in my calculator. Oh, I hit the wrong button. Let me try again. 18 squared plus 6 squared, square root of the whole mess. And I end up with a resultant of 18.974. And if I'm trying to keep this to 3 sig figs, which we typically do in our problems, this is going to end up being 19.0 miles per hour. Now remember, resultant always also has to have a direction. So for a direction, I am going to find the angle theta. I knew that this vector was going straight east, so east is 90 degrees. If I can add this angle plus 90, I can give it a compass heading. So let's find this angle. Let's go back to TOA and determine what trig function we need. This is the adjacent side, so I need a trig function that contains adjacent, so it's going to be either cosine or tangent, and I know the opposite side, so which one has adjacent and opposite? That's going to be tangent. So the tangent of my angle theta is going to be my opposite divided by my adjacent. Opposite is 6 miles per hour. Adjacent is 18 miles per hour. When I divide 6 divided by 18, that gives me the tangent of the angle. Then you're going to have to go second tangent, and I end up with an angle of 18.4 degrees. So the complete answer is 19 miles per hour, 18 degrees. Oh, I'm not done, am I? Because that has to be added to my 90. So my heading, I almost got away with that, didn't I? My heading is 90 degrees plus an additional 18.4. So 90 plus 18 is a heading of 108.4 degrees and at 19 miles per hour. All right, folks, that will do for this one. See you next time. Bye-bye.